So we will do linear regression using Excel. I already set a few important points. So I'll paste one more formula from here. Put it here. I had solved the problem earlier. So I'll put some standard things that have to be calculated from this sheet. Now this sheet is ready for certain calculations. So let's understand it one by one. So to calculate y is equal to ax plus c, we need to determine a. The formula for determining a is given here. So we'll first prepare the terms for this formula. So I'll just do plus first. So x into y, then x square into x square. So we'll take the both terms down. Okay. Here we'll do some important things. We'll take equal to sum each of these columns. And we'll extend this sum. We'll also calculate mean of y and x. So this is mean x, so it's equal to average we'll also calculate average of y. We've got all the terms, so we'll calculate now a. So number of terms are 37 here. So we'll put the regression formula. So this is equal to, we'll first do the first term. So it is 37 into summation of xy. So summation of xy, we get it here. So we get the first term minus summation of x into y. So this is x into y. This completes the numerator divided by n into x square, summation of x square minus we get a value. To get c value, we need to have y minus ax, where y is mean y and x is mean x. So we get this mean y is here minus, sorry, so here we have to write the formula. Sorry, this is mean y minus a into mean x. So this gives us the first two calculations. Now we'll put the regression plot here, the first regression plot, which is a xy scatter plot, or so this is density ln and this is versus y. put the, so insert a chart. So insert a scatter plot from here. We inserted a scatter plot. Select the data, add the data. So we need to select name. So name is, let's say, mobility. Select X values. So X values are here. Select Y values. So Y values are here. Okay. And so we get a plot. Okay. So this is the plot. Now to this plot, we'll add a trend line, which is the best fit line, and we can get the equation of the line. So the equation of the line, I will move it here. So you can look here, y is equal to 336.68. We also have got the same value, and the intercept is 1073.8. We have got it 103.7. This is what we do. Now we need to calculate the second step of the regression, which is called as residuals. To calculate residuals, we need to predict the values, that is, calculate y values using this equation. So to do this, we need to have a value into x value plus the intercept value. Okay, so we get residual. So this, then we need to calculate residual, which is y minus yp. So which is equal to y value minus predicted value. So we get the residual value. Now we'll keep this both the columns down. Okay, and now we'll plot another plot which is called as a residual plot. So residual plot is also a scatter plot, which should be, to accept the regression model, it should be random distribution. Let's see whether we get a random distribution or do we get a pattern inside this. So select the range. So to select the sense, it's a residual. Select x values. So x values will be same. Here we can put a plot against mobility, or we can put a plot against x values. Then, so ideally we will select x value to be mobility. Okay. And we'll select the y values as the residual values. Okay. Done. One minute. We have not got the. Let me delete first. Yeah. So we have not got the correct values here. So let me first get the correct values at this point. Oh, so we made a mistake here. So what is the mistake here is the a value, which is m. So it should be dollar and dollar, and even this value should be dollar. Okay, so that we get correct values here. And once we get the correct values here, we can put a plot, a residual plot. Insert a scatter plot. Okay, select the data. So add, select the range, add, select the x value. Okay. We can plot this against x, we can plot this against y, that is mobility as well as density. So we have taken these two. So we get plot. So this is the residual plot. When we get the residual plot, we find a pattern here. We also need to calculate two more values. We need to calculate coefficient of determination, that is R square, and coefficient of correlation. To calculate coefficient of determination, we need to calculate predicted value minus mean. So this is equal to minus mean of y. So when you put mean of y, put it using dollar, so that we will be able to put it square of this. Similarly, y minus y means original y. So this is equal to y minus y mean. Y minus y. Y mean is, you can get it from here, so which is, put it as again dollar, and take the square of this. So now what we'll do, we'll extend these values, just move this square. We get this value. To calculate coefficient of regression, we have to take square of the two values. Y minus y mean okay, so we made a mistake somewhere here. So let me put a formula again here. So this is y minus y mean. So y mean is this. So then C44. So here we made a mistake. So what is here? C44. So why is this? Y minus square of this. We'll extend this. We get the correct value. So coefficient of determination is ratio of sum. So we take this ratio. So this divided by this. So we get the coefficient of determination, and coefficient of correlation is sine square root. So this gives us the regression. We can do this regression very easily using the Excel tool, where we need to select only these two columns and we'll get the regression straight away. Data analysis, select regression, select y range. So y is mobility, so select it properly. So y is mobility. Okay, select x. So x is density. axis density, and keep the terms, and you get a new sheet which will show you all the plots. So look at the plots. The plots are, and look at the intercept value, and this. So this completes the total regression. So